On Sunday, March 3rd, 2013, at 3:30 p.m., South Essex Sewerage District Director Alan Taubert gets a phone call that no one wants to receive.
I got a phone call from Amy McHugh, Superintendent of Water and Sewer in Marblehead, who told me that there were seagulls in the harbor hanging around in one particular spot. I knew immediately that there was something seriously wrong out in the harbor that day.
The district suspected a leak in one of the twin pipes that delivered sewage from the Town of Marblehead to the South Essex Sewerage District for treatment. Unfortunately, this belief was correct. Divers from J.F. White Contracting found a broken section of pipe a few hundred feet off the Marblehead shore and performed an emergency repair using pipe the district had on hand for this purpose.
This is a section of the pipe that came out where the original leak was found, is right here. So when we excavated down the first day, this is where the hole was. But this is the piece of pipe that came out that was replaced.
Realizing the magnitude of the threat that further leaks could develop, the sewerage district acted immediately to hire a design team to thoroughly evaluate the pipeline. This confirmed that the pipes were in urgent need of replacement.
I'm Rachel Burkhart, and I'm the project manager with Parsons Brinckerhoff, and we were brought on board by the district here after they discovered the leak that was on the Marblehead end of the force mains that go from Marblehead over to Salem, to assess whether or not that leak was unique to that section of the pipe or what was the condition of the rest of the pipe. So our early work was to send in divers and find out what the condition was, do some non-destructive testing, and the conclusions of that phase were that the pipe indeed was corroded severely in several locations, and that particular leak could happen at any point in time on other parts of the pipeline. So our recommendation after that point was to replace the entire pipeline from one shore to the other.
As well as contending with the modern-day boating and recreational activities, working in this historic harbor presented special challenges. Native Americans used this location as a place for hunting and fishing, and state officials and local tribes believed it might be possible to find evidence of their ancestors' habitation in soils buried deep in the sediment below the harbor floor. To address these concerns, the design team used a VibraCore sampler to collect a series of deep sediment samples.
We had to do a series of VibraCores and then take those samples down to a laboratory at the University of Rhode Island, where an underwater archaeologist and his team examined them in great detail and analyzed whether or not they would have any findings. So we ended up doing 2 rounds of that. The first round was just along the length of it to see if we saw of anything of interest, and then we found one where there might have been some potential paleosols, which was in a layer where it was a salt marsh that existed 7,000 years ago. It now is about 10-20 feet into the muck, but that's where the sea levels were at that particular time. Eventually, after a long, lengthy process, because this was only one of about 5 permits we needed to get, that we finally got to getting the permits and getting into the construction phase of the project.
With project permits and approvals in hand, the district was able to proceed with the bidding of a construction contract to install new pipelines beneath the harbor. At an initial contract value of $9.4 million, contractor Caldwell Marine mobilized into Salem, Massachusetts in mid-January 2015. As the contractor made initial site preparations, winter 2 geared up for a record-breaking season, officially making the winter of 2014-2015 the all-time snowiest in the Boston area. Even with all the snow, Caldwell continued to assemble their equipment and materials while they maneuvered workboats and barges into Salem Harbor. Because sanitary waste is continuously being flushed and drained into Marblehead's sewer system, there was no effective way to stop the flow during construction of the new pipeline. For this reason, the pipeline construction was carefully phased to ensure that sanitary sewage could continue to flow from Marblehead to the South Essex Sewerage District's treatment plant without any loss of service. During the first phase, the pipelines were installed across the Federal Navigation Channel, the deepest part of the harbor. Special flanges were fabricated at each end to allow for future phases of the pipeline to be bolted on. This phase required a trench to be dug to place the new pipes, while the old pipes remained in service, carrying wastewater out of the town of Marblehead. In order to accomplish that goal, Caldwell Marine subcontracted with J. Cashman Incorporated, which brought in the Captain A.J. Fournier excavator dredge barge. This dredge barge excavated the majority of the trench through the winter and spring. The trench was located parallel to the existing pipelines, but far enough from them to avoid the risk of damage. When the trench was complete, the new pipes were installed, at a depth great enough to provide a minimum of 5 to 6 feet of cover over the top of the pipes. The trenching and offshore pipe installation were the pivotal first steps to prepare for all future phases of the job. The existing ductile iron pipelines were installed in the mid-1970s as part of the 74-17 Marblehead Force Main and Pressure Sewer project. With these pipes failing in less than 40 years, the district and design team worked to select new materials that would provide superior long-term performance.
This piece here is a section of the new pipe that just got installed. This is a high-density polyethylene SDR11. It's basically a garbage bag. It's just, this is 2 inches thick.
Using the HDPE pipe material, along with bolts and flange backing rings made of C276 Hastelloy steel, one of the most corrosion-resistant alloys available, the design team hopes to achieve the goal of providing a 100-year service life. Raw sewage from the town of Marblehead travels over 6,000 feet to the treatment plant in Salem. To create pipelines of this length, a pipeline assembly area was established on the Salem side of the job. Sections of the new pipe are fused together using 2 McElroy fusion welding machines. These machines plane the pipe ends to ensure a square fit. A plate then applies heat at 400 degrees Fahrenheit for around 15 minutes. When ready, the machine presses the 2 pipes together, applying 425 pounds per square inch of force. Once the proper weld bead is formed, the pipe is allowed to cool for 30 minutes. This creates a fused joint that is stronger than the pipe itself. On the inside of the pipe, the raised bead could cause drag or become a potential area for debris buildup. To create a smooth interior at the joint, the bead was removed from the pipe interior using a specialized cutter head. Technicians had to time the removal process precisely to ensure the fused joint cooled to an optimum temperature. Too hot, and the tool would dig too deep. Too cool, and the bead would be too difficult to remove. Over the course of building 2 6,000-plus foot-long pipelines, this fusing and debeading process was repeated over 250 times. Strings of pipe 500 feet long were pre-assembled on land and fitted with caps that allowed the pipelines to be pressure tested 1 section at a time.
My name is Scott Williamson. I'm with Parsons Brinckerhoff Engineers, and I'm the resident engineer on the project for the district. Well, marine construction is, as you'd guess, it's all underwater. So we put testing programs in place. We water test, we air test, we make sure the pipe is all assembled with tight joints. There's about a mile of it underneath the harbor. Actually 2 miles when you consider that there's 2 pipes, so each of those pipes get tested. This is what we do to just confirm that the pipe will hold pressure and hopefully last 100 years.
Let's get it this way as far as we can, and then we'll move the machine like this. Try to shoot it over this way more. Let's try to get in here as far as we can.
The 500-foot strings were then floated to the barge, where they were fused together into longer strands. Pipeline installation utilized a float and sink technique to install the pipes. To offset the buoyancy of the pipe, specially shaped ballast blocks or collars, each weighing close to 7,000 pounds, were precast out of concrete to cradle the twin pipes. To provide the required ballast and sink the pipes into the trench, these blocks needed to be attached to the pipes every 15 feet. Over the length of the alignment, the ballast blocks weighed in at over 3 million pounds. A unique numbered nameplate, machined from galvanized steel, was anchored to each one of the blocks. During future inspections, these number plates will give divers a tactile means to positively identify a block, even in the murky harbor floor. Once completed, the finished pipeline assemblies were floated into place above the excavated trench. Even with the ballast blocks assembled onto the pipeline, the empty pipes were buoyant enough to float. Working from a lay barge, one of the pipes was filled with water at a controlled rate to allow the pipeline to sink gradually into the excavated trench. Divers monitored the sinking of the pipes to verify that they rested properly at the bottom of the trench.
I'm Brett Bryant, Caldwell Marine, and I'm the diving superintendent. When we were sinking, you're sinking both pipes at the same time, so our engineer Patrick Lynch had a valve set up that he could make sure as the pipes sank, both of them were going down at the same time rather than one flipping like this or the opposite direction. Usually it was never out a level more than a foot or two. The only way the diver could tell is when he was on the bottom. When the blocks are setting down, he'd see one side hit before the other side. We got one guy on the radio and a couple guys tending, one guy in the water, and the guy communicating to the diver back and forth. He's basically talking to the diver, and then myself or Eddie Mendler, somebody would always communicate with the tugboat. On the other boats, we had various boats along the line, pushing the pipe to where it needed to go, and the diver would say, need to slack it to the east or push it to the west, depending on what side the boats were on and what in the different position we were actually sinking the pipe.
I'm Patrick Lynch. I'm the project engineer for Caldwell Marine. I do a lot of the engineering duties, so once we actually install the pipe, I create all the drawings to send to the client. I also oversee a lot of the field work that's been going on. So this is actually showing the blocks coming out of the portion that was in the channel that was previously backfilled and coming into the new trench. So you can see the trench here on both sides. This is the side slope of the Marblehead navigation channel, and each one of these here are the blocks we installed, and the pipe is obviously in between. When we dug this trench, we put all the material here, laid the pipe in. Now we're going to grab all the material from either side and put that back into the trench to cover up the pipe, which you can see here at the blocks. So these surveys are also used to input this into the high pack on the dredge on the crane, and then they know how much material is in each location, so they'll know where each one of their buckets is, and they'll take all this material and put that back in. Then that's how we know that we're getting back to grade.
Once the pipes were installed through the offshore region, a temporary bypass pipeline was connected across the inshore sections and connected to one of the existing pipes on the Marblehead and Salem shores. This allowed the district to transfer flow out of the old pipes and into one of the new pipes. To divert flow on the Marblehead side, a specialized tap and line stop were installed onto the existing 30-inch sewer.
Just like that. Stay right there. Down a touch.
Down a little bit? Yep, there you go.
Ductile iron pipes and fittings and a mechanical joint were then used to make up a temporary bypass connection to one of the newly installed 24-inch HDPE pipes. Similar work was required on the Salem side of the job. Temporary ductile iron pipes were connected to HDPE pipe. Construction crews installed a specialized electrofusion coupling to join two HDPE pipe segments. A temporary meter was installed to track flow. With the bypass in place and ready for operation, crews carefully coordinated valve operations to allow wastewater to flow into the new bypass pipe and to shut off flow to the old pipeline.
Go ahead, are you standing there? What do you got?
We are here, and we're pretty much ready to get going.
Okay, we'll close ours first, huh? Correct?
Yep. You can start, because it'll just divert.
We'll start slow.
Yeah, the flow will just eventually divert over to the 24 anyway.
With flow safely transferred out of the old pipe, crews began making necessary modifications to accept the new HDPE pipe, as well as rebuilding components of the vaults located on the Marblehead and Salem shores. Crews could now expose the old ductile iron pipes and begin removing sections to make way for the new HDPE pipes. New HDPE pipelines were connected to the existing 30-inch asbestos cement pipe using a specialized coupling and custom fabricated HDPE Y fitting to split the flow into the twin pipes that enter the harbor. Modifications to the Marblehead vault included the installation of new gate valves to isolate and direct flow. Valve operation allows flow to be directed into either pipe under normal flow conditions, or to use both pipes in periods of high flow. The Salem vault also needed to be prepared to accept the new HDPE pipeline. Wall flanges were made up with new nuts and bolts. Acceptable ductile iron spool pieces were reused and cut to length to make adapters to which the HDPE pipe would be connected. Exposed ductile iron components were surface treated with a bituminous coating and sealed with a polypropylene wrap to minimize the potential for corrosion. Once the vault was prepared, HDPE pipes were floated above the near-shore trench where connections to the vault were waiting to mate up with the new pipeline.
Once you get that little float set up, you'll swing over, pick up the offshore portion of the main line, bring it up onto the float. Reach over, grab this section we're going to add in. Pop the hatches on them and start bolting them together, and then when they get it secured, we're going to start moving it over into the channel, and then we'll go to the other side and start flooding it, and the diver will put it in the channel.
The Salem vault received a new flow meter, which is used for tracking and billing purposes.
As you got closer to the shores, though, the shore tie-in pieces we had to keep long. Obvious reasons, we were tying into a dead spot there. So we would usually make the pipe 75 to 80 feet longer than it needed to be. And we had a couple curves to go through, setting it down. So as we would go along and the pipe is sinking, the guys on the beach would have to cut it back. And we didn't want to cut it back all at once because you don't want to cut yourself short once again. So we would cut 10 feet, 12 feet in the trench boxes, and as they would cut it, it would free it up so it could freely move forward, and as they're sinking it, we were able to maneuver it around as it went into the trench boxes.
Make sure that it's up on the side and start having Patrick sink as they come. Roger that.
Average day of sinking, whether we were near shore or inshore, was usually about a half a day of sinking. Because we weren't digging that day, as the tide ebbs and floods, we'd usually get some good visibility for the sink. The first block that hits the bottom is pretty much neutral. So the tugboat was able to, as stiff as the pipe is, he could push it, and that block would actually slide along on the bottom if you weren't quite in the trench. And the diver would walk, he would go back and forth on the pipeline, so he could tell how much the blocks were sinking down into the mud. You know, when the diver's giving us information, it's going from the guy on the radio with the diver to the guys with the VHFs, and we're all on the same channel. So if I'm telling the tugboat to come to the east, the guy with the Carolina skiff, he gets the gist of what's going on. He generally didn't have to respond. He knew what was going to happen. And after we got the first sink out of the way, got the bugs worked out of it, pretty much everybody knew what was going to happen, and there was a whole lot less chatter on the radio.
Once the first permanent connection was readied, the bypass connection was closed, and flow from Marblehead began flowing through the new pipeline. The second pipe was connected shortly after Labor Day, completing the new sewer connection. To complete the project, what remained was to backfill the remaining sections of pipe trench, complete work on the Marblehead and Salem valve structures, and restore the shoreline on the Marblehead and Salem sides. Multi-beam sonar surveys of the harbor bottom were performed to verify the backfilling of the trench and the restoration of the harbor bottom profile. A dive survey of sensitive harbor eelgrass beds was performed, which confirmed that these aquatic resource areas were not damaged during construction. Through this project, the South Essex Sewerage District successfully removed a potential environmental hazard and replaced a leaking sewer with a state-of-the-art pipeline.
Us, the contractor, and Parsons and Brinckerhoff, I think everybody did well because it was a quick job too. It was something that, especially for Parsons, it was we need to get this thing designed, we need to get it out on the street, and we need to get it done as soon as possible. And then, the time of year to install it. The time of year is just horrible. And it was the worst winter we've had in 30-something years. I know we did a good job, and I know that the pipe is a good product. HDPE pipe is incredible stuff. It was a success for Marblehead and SESD.
It actually went pretty fast. Even with the delays, we got it done pretty quick, considering what is required to install a pipe like this across that harbor requires significant permitting. And to get that all accomplished in 8 months actually was pretty fast for the size and scope of the project, if you forget about the emergency side of it. But we made it. Pipe didn't leak. At the end of the day, we didn't have a catastrophe. I don't think it could have worked out much better than it did, to tell you the truth.